So here we're going to get a little bit smarter, you guys. So we're still working on positive and negative intervals. Notice this says find all intervals where f is positive. So nothing new, except we haven't been given the graph this time. So before it was pretty obvious given the graph where the function is positive or negative because you just look for where it's above or below the x-axis. Here, not so obvious, right? So we're going to introduce a method that you can do even without a calculator. And then we'll also introduce in the second example a little trick to make it easier using a calculator, make it go a little bit faster. So our first step, and part of this is already done for us, is factor our function and set equal to 0. Okay, so that's our first step. Factor meaning turn it from a polynomial with a bunch of terms to factors in parentheses like that. So that's already done for us. And then we're going to say 0 is equal to all that. Because what we're doing is we're trying to find the zeros of this function. And that's our first step to figuring out. Our sign chart is figuring out where the zeros are. So setting this equal to 0 means we set each factor equal to 0. This is nothing new to us. And we solve for what we get. You guys have been doing this now for 2 years. Okay. And then what we're going to do is we're going to make a number line with our zeros. Okay, so let's think left to right. My smallest one comes first, that's -3. Then 0 comes next, and then 6. So our second step is make a number line with zeros. Okay, and then what we're going to do now is we're going to test. So notice our number line kind of is divided up into 4 regions here, so I'll write them real quick so you can see what I mean. So we have 1, 2, 3, 4 regions. We want to know whether the function is positive or negative in each of these regions. So I can pick any x to plug in to test the sign. I don't have to solve the whole function, although that's what I'll do here, but I do need to figure out whether the function is positive or negative. So let me show you what I mean. I'm going to start with these middle 2 intervals, although the order we go in doesn't matter here. So in this interval lies x equals 1, and I picked 1 because it's easy, right? So I could have picked 2 or 3 or 4 or 5 all the way up to 6, right? But I just picked 1 because it's easy. So at x equals 1, I'm plugging it into my function here. I'd have 1 squared times 1 minus 6 squared times 1 plus 3. So what does that give me? 1, and then -5 squared, and then times 4. Okay. Notice these are all positive, right? So 1 times, this looks negative to start with, but when we square it, it becomes positive, right? So we have positive times a positive is still a positive, times another positive is still a positive. Okay. So on my sign chart, I'm going to make this a plus region. So this is one of my intervals where f is positive. Okay. And then if I solve that right, I can just double check. 1 times 25 times 4 is 100, positive 100. So it is indeed positive. All right. Then over here, to the left of 0, but to the right of -3, I might pick x equals -1. Again, I'm doing that because it's easy, but I could pick any value here. And that would be -1 squared I would get, and then -1 minus 6 squared, and then -1 plus 3. Okay. So again, we have positive, positive, positive. So positive times a positive is still positive, and then times another positive is positive. Okay, so we're just checking the signs, and again, I could figure out the math here. We get what? 1 times 49 times 2. What does that give me? 98. We just care about the sign, though. And then we're going to check these outside regions. So here I might use x equals 7. And that gives me 7 squared times 7 minus 6 squared times 7 plus 3. And then that's, again, 3 positives. So this region is positive. And then we'll check my last one. So here, we'll do x equals -4. And what I'll get here is -4 squared, which is positive, right? Give myself enough room. So here we have positive, positive again, because these are both squared, right? And then negative. So this last region is negative. Okay, so let's return to our original question. So we've checked for signs now by plugging in x values. Our intervals where x is positive, well, that would be, let me highlight them. That would be from here all the way to the right, right? We got positive values in all of those. And I know it doesn't change signs again because it's never equal to 0 again, right? So it has to be positive forever. So my positive intervals would be from -3 to infinity. So that's a sign chart. So again, we're going to plot the 0. We're going to make a number line with zeros. And the last thing we did is we picked x values to check the sign in each interval. Pick x values to check the sign in each interval. Okay, so that's a sign chart. So somewhat time consuming, but the advantage is you don't need the graph or the calculator. In the next example, I'll show you how to do it a little bit quicker with the aid of a calculator. So here we have another example, and notice here we're just given a quadratic, and we want it to be greater than or equal to 0. So we'll start with a similar move here. We'll factor, right? So I want two numbers that multiply to -10 add up to 3. So that would be x plus 5 times x minus 2. I'm going to set that equal to 0 to find my zeros, right? And I get x equals -5, x equals +2, my zeros. And then I'm going to plot them, right? And then -5 and 2. And then I have 3 regions to check, right? So here's a little trick to make this part of this much faster. So I'm going to use the graph here in my calculator. Like, obviously, you could figure out the positive regions just from the graph, right? But here's just a useful trick for evaluating these. So I'm going to do second calc value. Second calc value. So those are my keystrokes to get here. And then I'm just going to type in any number within these intervals. So I'll start with my first interval over here. I'll type in -6. I guess -9 works too. Any number to the left of -5 will work, right? And then I get a positive number, so I'll just note real quick that that's positive. And I don't really care what it was, right? I just care the sign of it. So first interval is positive. And then my second interval is between -5 and 2, and I'll just plug in 0 here. And I can just hit 0 now, and it overwrites it, which makes this super fast. So -10. So I get negative here. And then my last one, bigger than 2, so we'll do 3. And then I get 8, so positive again. So that's pretty quick, right? That's much quicker than just typing this into our calculator every single time. And then if we want greater than or equal to 0, well, those are my positive regions. So I'd say from -infinity, and here we'd include -5, so it gets a bracket because of the or equal to, right? And then also to infinity. And again, 2 gets a bracket, infinity always gets parentheses. So there you go. Those are sign charts, useful for solving inequalities or figuring out, the sign of a function in a certain spot.